Hello, today we're going to be talking about the modeling cycle and we're going to talk about linear models. So, first, looking at the modeling cycle, we have to understand that there are going to be five main steps that you take in order to solve problems. So, step one is that you want to ask a real world problem. When you ask this problem, you are going to make sure that you take notes of any key information to help simplify the problem. Step two is that you want to create a model, which is a formula or an equation that's going to represent that problem using math, numbers, and letters. Make sure that you consider the constraints of each variable to make sure that you are staying within certain guidelines. Step three, you are going to test the model by comparing the predictions of the model with the actual known data. If the model is wrong when you test it, you will need to revise the model by rejecting it and making changes to it and then testing it again. Um, Once you have tested the model, if you have had to reject it multiple times, or once you test it and you can accept it, once it is accepted, you can reflect on the model and then use it for an initial problem or another problem, okay? And be making sure to interpret the solution in real world terminology. And then step five, if needed, you can extend the model to make it more precise if you need to. So let's look at an example here. So it says Paula takes 4 hours to clean the house. Jordan takes 6 hours to clean the house. How long would it take to clean the house working together? So if Paula takes 4 hours to clean the house, then that means that in 1 hour, she will take and clean 1/4 of the entire house each hour. Jordan takes 6 hours to clean the house, which means that in 1 hour, he will clean 1/6 of the house. So if they work together, adding them together, that means that they will end up cleaning 5/12 of the house together every hour. So it says here that we want to know how long would it take for them to clean the house if they are working together and they want to clean the entire house. So cleaning the entire house means that they want to clean the whole house, which is equivalent to the number one that represents one whole. And they're going to divide the whole house into sections of 5/12 because that is the amount that they clean every hour together. So if I take one and I divide it by 5/12, I will end up getting 12/5. And if I make it a decimal, that'll end up giving me 2.4. So that is 2.4 hours. Now, in the real world, we never talk and say, oh, 2.4 hours. If anything, we have to convert our hours to minutes. So I have 2 hours, but now I need to figure out how many minutes zero point 0.4 of an hour is. Well, zero point 0.4 of an hour means that I need to take zero point 0.4 and multiply it by the number of minutes in an hour, which is 60. And I will end up getting that will be 24 minutes. So 2 hours and 24 minutes is how long it would take for Paula and Jordan to clean the house together. Okay, so now let's look at linear models. So we know that two variables are linearly related. Whenever you have a graph connecting them, that graph should end up making a straight line. So it says here, Cheryl, the Uber driver, charges $2 plus $3 for each kilometer driven. We need to complete the table below. Normally, when we complete tables, we have we normally start with 0. And we know that the distance is going to be X and the cost is going to be Y. So normally when we do this, we will start off with 0, 1, 2, 3, and 4. Now you can choose your own X values. You do not have to choose 0 through 4. You can go in any order that you want. And then we have to find the associated cost. So if you don't drive any kilometers, you still have to pay the Uber driver $2 for coming to you. So that is going to cost $2. Then for an additional kilometer, you're going to end up having to pay a total of $5, then $8, then $11, then $14. So now we need to graph this And when we graph it, we need to make sure that we label and scale our axis. So here we have our x-axis, we have our y-axis. So once we scale our axes, we also need to make sure we number them when we draw our axis. So the highest y value is 14, so I'm going to go by twos. So 2, 4, 6, 8, 10, 12, 14, 16, 18. And then for my x values, just to give myself some room, I'm going to skip every other grid line and I'm just going to go by ones. So technically I'm going by halves for every marking. Every other marking will be 1. So once I do that, I can just plot my points where they belong. So 0, 2 is here, 1, 5 is here, 2, 8 is here, 3, 11 is here, 4, 14 is here. So now I can connect these points with a line because I can drive as many kilometers as I want to. So it says the graph of distance versus cost is a straight line. So we can say that D and C are linearly related. Okay. And because we use the variables D and C here, I know that on my x-axis, I can put D for distance and C as the cost instead of using X and Y. So if we look at this graph here, we know that the y-intercept of that graph, the y-intercept is 2. That is going to represent the initial fee of the Uber ride. Then the gradient is the slope. The gradient is the rate of change. And that gradient is 3, and that's going to be the cost of each additional kilometer that is driven. The linear model that is going to represent this situation is going to be C, which is the same thing as Y, is equal to 3x, or 3D for the kilometers, plus 2. So when using a linear model to approximate values outside of the range of given data points, this is what we are going to call extrapolation. Okay, extrapolation is when you are approximating values that are outside of the range of values. We also have interpolation. That is when you are predicting values inside of the range of values. Okay, so predicting inside the range of values. So when we have extrapolation, a lot of the times that is not accurate, okay, or it can be accurate sometimes and not accurate in other times, because let's say you are looking at the number of days that you leave your dog in a doggy daycare versus the cost. So let's say I have 5, 10, 15, 20, 25, and the cost for leaving your dog at the doggy daycare for this amount of days, let's say, is 52, 126, 241, 281, and 394. Okay. If I'm predicting how much it's going to cost for me to leave my dog in the doggy daycare, and I'm choosing a value that is in between 5 and 25, that will be more accurate because it is in between the values that are already given for the type of equation that I get. However, if I try to figure out the cost of the doggy daycare for the number of days less than 5 and greater than 25, I'm running a risk of not being accurate, because one thing that I noticed about the cost is that the cost is not behaving linearly. It's not the same rate of change like the days are. It doesn't reflect the same as the cost. So that means that it may not move the same. So extrapolation is when you're going outside of the range of the given data points, meaning you're going outside those given x values. That can cause an error. Interpolation is accurate because you're inside of the range of x values, which would have been covered or taken into consideration because the points that are around those numbers that are on the inside were already taken into consideration and given. So if you have any questions on modeling, and if you have any questions on linear models, please let me or your teacher know, and you all can have a great day. And make sure that you highlight the part for inside for interpolation there. All right. Have a great one.